A large class of compounds, called the hydrocarbons, consists of only two elements, hydrogen and carbon. They originate from petroleum, that is, crude oil, natural gas, and coal, all fossil fuels. Many others are also synthesized from these products. To help get a handle on them, we're going to start a flowchart. As we develop this flowchart, it may look quite involved if you haven't studied this area yet, but it's meant to give an overview. There are other ways to classify that may be more detailed and comprehensive, but this will be a good start for beginners. The two major divisions are the aliphatic hydrocarbons and the aromatic hydrocarbons. The aliphatic carbons are fat-like in the sense that, like fats, they are less dense than water, like oil floats on water, and insoluble in water. There are three types: straight chains, branched chains, and saturated rings. I'll pause here briefly to show what they mean. Straight chain hydrocarbons are often written like this. Each atom is shown, as well as the bonds that connect them. This can be quite cumbersome, especially with larger ones, so often it can be shortened to this kind of format. Models show a more realistic version of the molecule in real life, that in fact they're not literally straight, but they have more of a zigzag shape like this. Again, to simplify the way they're written, they can be written like this. It is understood that at the ends and at the corners there is a carbon atom with 2 or 3 hydrogen atoms attached, so that the 4 bonds required for carbon is satisfied. Here's a case where there is one branch. Again, this can be written more simply like this. Here's a model of a different molecule, and here is a representation. It's again a different molecule, a larger one, but is shown here with 3 different branches. The saturated ring, like this, again shows all the atoms. It can be more simply written just like this hexagon. Again, understood that at each corner there's a carbon atom with sufficient hydrogen atoms to satisfy the 4 bonds required by carbon. Coming back to our flowchart, let's look at the aromatic compounds. They contain the word aroma. So they are known to have smells and odors, some of which are pleasant and some very much not. The key ingredient of aromatic compounds is the presence of the benzene ring, whose molecular formula is C6H6. It can be represented like this. The 6 carbon atoms form a ring, and 1 hydrogen atom is attached to each carbon atom by a covalent bond. You can see 3 double bonds in the ring. Here's another representation showing just the 3 alternating double bonds. Again, it is understood that at each corner there is a hydrogen atom. And a third and even simpler way is just a hexagon with a circle in it. These representations will be explained when you get there in the unit. Now back to the aliphatics, and see that they are divided into 2 groups, called saturated and unsaturated. The word saturated means that all the bonds are single bonds, while the unsaturated hydrocarbons have 1 or more double or triple bonds. The aromatics can be divided into 2 groups, benzene and its derivatives, and fused rings. An example of a derivative of benzene is a molecule called toluene, with CH3 attached to one of the carbons. This is a smelly, colorless liquid whose fumes are dangerous, however, to breathe. Under fused rings we have this kind of structure, consisting of 2 benzene rings connected or fused together. It is known as naphthalene. It has a mild odor that is not very pleasant for humans, but distinctly unpleasant for moths, which is why it is used to make mothballs. Now, although the aromatics can be further subdivided into many other classifications, for our purposes in this first course, we're going to stop here and focus our attention on the aliphatics and see how the left side can be further classified. Saturated hydrocarbons are further divided into alkanes and cycloalkanes. Another term for cycloalkane is cyclic aliphatic. which refers to exactly the same type of hydrocarbon. The unsaturated aliphatics are further subdivided into alkenes and alkynes. If you look carefully at these names, they will give us a clue to the description above. For example, the ending ane indicates that all bonds in alkanes are single bonds. The E in ene indicates double bonds. And the Y in yne indicates that there is a triple bond. Now, these hydrocarbons can all be characterized by their own formula. So, for example, alkanes are described by the formula CnH2n+2, where N is the number of carbons in the compound. Let me illustrate by using the formula CH4, which you know as methane, or methane gas. We have N equals 1 here, and if we double 1 and add 2, we get 4. So that's how we get CH4. If I asked you to write the formula for a hydrocarbon that has 100 carbons in it, you could easily do that by simply doubling the carbon number, so that would be 200, and adding 2 to that, making it 202, giving us C100H2O2. Cycloalkanes have their formula, CnH2n, and similarly the alkenes have the same formula as the cycloalkanes. The reason for their being the same has to do with how the structure changed from a cyclic structure to a double bond structure. That will be explained when you get to that part in the unit. The alkynes have the formula CnH2n-2. So this is basically our flow chart. After you have studied the unit, this chart can serve as a succinct summary. This ends the introduction to the classification of hydrocarbons.